Hello, my name is Haida Karumi. I am presenting my doctoral thesis today. The defense has taken place on 3rd of May 2021. The topic is Instrument for Measuring Sustainable Success in Software Development. As a graduate engineer in electrical engineering and with a master in sustainability and quality management, I present to you today the content and the results of my doctoral thesis. The first thing I'm going to do today is introduce what I'm going to talk about today, which will be presented for discussions. What is the initial situation? What is my setup and how did I proceed? Then I present the result of the theory part. Then follow the result of the empirical part, where I then conclude with a summary and conclusion. What was the initial situation? I have chosen a practical problem in software development that consider many reasons why the development projects and software products fail. Because of the problem, the doctoral thesis aims to develop a tool for predicting sustainable success in software development. The goal is achieved when green software indicators are considered in software development in general and especially within the risk management process. The research gap of the doctoral thesis consists of the theory that the topic of green software is not new, but there are lacks on tools for stakeholders to use green software in development by considering the product life cycle. There is one main research question and two sub-research questions. The main research question stands for the following. If the green software in its aspect and indicators are considered in the risk management process, then software development projects end up more successful and provide sustainable products on the market. The two sub-research questions refer to the reduction of development costs and the increase of quality. If the green software indicators and aspects are considered in the risk management process, in the mean of analyzing risk, evaluate them, and documenting them. The theses of the doctoral thesis are divided into structure covering thesis and cause analysis. Thereby, they refer to the if-then analysis and questions as well as the root cause analysis with the question using the more clause. For example, the more it rains, the more I am getting wet. The thesis aimed to integrate the sustainable goals in its three pillars of economic, social, and environmental pillars in the value chain of software products, so that the topic of green software has a forecasting tool to close the research gap and can be considered in the risk management process. The prediction of sustainable success in software development represents an advance in knowledge of the state of the art and in actual practice. Closing the research gap and integrating green software into the software product value chain represent a step forward in knowledge and in science. As described in the initial situation, the thesis is divided into parts, starting by the beginning with an introduction as well as a problem definition and an objective. The second part is divided into a theory part and empiric part. The theory part describes the state of the art and the basics. An indexed elaboration of success and risk factors of the software development in general and green software indicators in special were set up. The empiric part divides into the qualitative research method as a preliminary investigation and quantitative research methods as a main investigation. The qualitative research as a preliminary investigation is conducted in the form of expert interviews, followed by content analysis. The main investigation as a quantitative research method is conducted in the form of survey followed by data pre-processing and evaluation. The empirical part was made using computer tools. In the following, the results from the theory part and empirical part are presented. In the theory part, success and risk factors in software development in general and in green software in particular were researched and selected as well as indexed so that the preliminary tool as well as a concept for forecasting can be established based on the literature. On more results, furthermore, the concept was structured in such a way that influencing factors were selected as independent variables, which influence a dependent variable in the three dimensions: social, economic, and ecologic. At the end of the theory part, the necessity of integrating the green software indicators in a practical tool such as the risk matrix, which is a component of risk analysis, assessment, and documentation in risk management process, was presented. In the following, after the theoretical part has been presented, the empirical part is presented, which was carried out with a planning and process. The empirical part is divided into qualitative research methods as a preliminary investigation and quantitative research method as a main investigation. The qualitative research as a preliminary investigation is conducted in the form of expert interviews and subsequent content analysis. The main investigation as a quantitative research method is conducted in the form of survey followed by data pre-processing and evaluation. The empirical part was made using computer tools. In the following, after I showed you the plan and the process of the empirical part, the results from the empirical part are presented. In the qualitative empiric part, there was 3 expert interviews which has been executed, transcribed, documented and analyzed with a subsequent content analysis so that the theory part was examined, confirmed and extended with further green indicators and success and risk factors of software development respectively. The chosen substantial green indicators represent the results by considering the software life cycle and its value chain, so that the indexed indicators are limited only to the substantial factors around the research question to be able to answer them as well as to close the research gap. The following 5 indicators were the results from the expert interview and subsequent content analysis. Default setting, tools and management approach, user information, interpretability and test, interoperability and reuse. The 5 elaborated approach as an independent variable from the content analysis were pragmatically set up against their related indicators and the sustainable success as dependent variable, so that the preparation of cause-effect analysis can be prepared and conducted by a survey. In the following slides, the results from the quantitative empirical part are going to be presented. The survey is conducted with 48 responses. The subsequent data pre-processing and analysis revealed that 9 significant independent variables affect sustained success as the dependent variable. The model summary shows this result. In the following, the results of the regression models are described in more details. The analysis of the survey has been made with SPSS. The ANOVA statistic shows that the results are significant. The thesis made clear that the premise and preconditions of the linear regression has been considered. The strength is 0.742. A linear relation between independent variable and the dependent variable is significantly represented in the equation. Furthermore, in addition to the significant results, a direct relationship between economics factors and the associated ecological factors was found. In turn, the results have shown a direct correlation between ecological factors and the associated social factors, which ultimately represent an indirect correlation between economic and social factors. The coefficients of the correlation matrix can be used as a quantified control measure to mitigate the risk, which can be used in practice in the risk matrix. At the end, the results of the doctoral thesis have been presented. The coming slides show summarized results and the conclusion. The question of the practicality of the forecasting tools remains open. One possible application is to use the forecast when stakeholders are deciding the project contract. But what about the risk analysis? The quantified correlation relationships can be used in the risk matrix as a mitigation measure of the risk priority number. One more example. The results achieved by this doctoral thesis can be used throughout the company and the system as a benchmark in addition to safety and security, so that system requirements can be derived from them. Thank you for your attention, and now the discussion and final evaluation may take place.